Hi, good morning. So we don't need more introduction. So what I'm going to describe to you is the work we are doing on behalf of the European Commission on putting together a climate data store. I'll give you the URL so you may want to play with it while I do the presentation here. So first, let's have some background. Copernicus is the name of a European program for the Earth observation. So that really also covers space component, in situ component, and service component. It's a €4.5 billion euro program, and most of it, of course, goes into the space component. So what I'm going to present to you is the climate service, which is one of the services. Yeah. So there are 6 services. One is marine, one is climate change, one is security, atmospheric chemistry, land, and I'm missing one here is, never mind. So ECMWF is in charge of 2 of those, which is the climate change service and the atmospheric chemistry service. And the idea of the European Commission is to develop value-added service that are called downstream services. So the Commission has entrusted ECMWF to implement the climate change service. And the idea of this climate change service is to create a knowledge base to support adaptation and mitigation policies. That's a sort of architecture we are putting in place. These are functions with people here. You have a climate data store in the middle. You have a sectoral information system below. I'm going to go back to that, which use this data and contribute back to the climate data store. You have a very important function is the evaluation and quality control, and then you have outreach and dissemination. So what we want to do is to provide access to climate data, but also tools, support the sectoral impact, provide quality assurance, user support training, and climate change assessments here. The data we are going to archive or to make available through the climate data store are observations, reanalysis, and model output. So we have we really cover all the aspects. What's important here, for example, at the bottom, you see CMIP is part of the portfolio of data sets we need to make available. Our reanalysis as well are part of the portfolio, as well as all sorts of satellite and in-situ observation. The sectoral information system, these are the sectors we are trying to support: water management, forestry, tourism, insurance, transport, and so on. So what we want to provide is sufficient climate information for those sectors to make use of climate change information. Yes? Yes, but we are going to support all of those, but it's a staggered implementation. So for now, we are only, I think, doing water management, transport, tourism, energy, and health. The rest will come later. So I told you earlier that the European Commission has entrusted ECMWF to do that service, which means that, so the European Commission is a bit like the NSF for you. It's the founding entity, and they have provided the funding facility to ECMWF to actually redistribute these funds to other entities. So although ECMWF will be putting together the climate data store, we are going to outsource, if you want, all the other activities of the climate. So far, we have 26 countries with SECPA, and we have been running up to 90 contracts to have, as I was saying, energy, health, and so on. So now I'll go back to where we started. So this project is 2 years in the making now. So the data exists, but it's everywhere in different data portals, and you need to be an expert in order to retrieve this data. So we had a workshop at ECMWF 4 years ago now, and the definition of what the climate data store was done at that moment. It has to be distributed. That was a requirement from the European Commission, because we did not want to duplicate the data, but it has to provide a one-stop shop. The data must be open. There must be some software which is also freely available in order to manipulate this data. And the data store should contain observation, reanalysis, and forecast, seasonal forecasts and projections. So I don't know if you recognize Dick here, Steve, but at the time they came to me and say, how can we do that? And Dick, which is a colleague of those two persons that were in charge of this project, they came to me and say, how can we achieve that? And Dick D, which is a colleague of Steve here, was really like IRI's map room facility. So I think that was something we wanted to copy here. So at the time we say, if I go to Amazon and I was looking for HDMI cables, you have a list here, and you see that you have different data providers for the same sort of data. And so what Amazon is actually, apart from providing data itself, is a broker. So we wanted to do the same sort of system. It's a marketplace, so we have one single entry point, but you have a broker. So if a user places an order through the web portal, the request is brokered to a provider, which even in the case of Amazon will deliver the goods directly to the user. And the user, I don't know about Amazon, but I suspect can publish its own list of goods into the Amazon catalog. And the user will search this catalog. So that's the model we wanted to have. A single catalog, a web portal, and a broker. And if possible, direct delivery from the data provider to the user. So in order to implement that, we wanted to implement a system of adapters. So an adapter is a very common programming pattern, but it's also what you see on the picture here. You have a mismatch between what you want to do and what exists, and you build an adapter. And so what we've been developing through this CDS is a series of adapters that supports various protocols, simple HTTP, FTPs, opened up, and we also have a connection with the ESGF and ECMWF own archive. And the idea being that each time we have a new data source, either the protocol already exists, or we just build a new adapter to access this data source. The toolbox, we really wanted to mix data from different sources. So we had to come with a sort of terminology here. Tools, which are computer programs, which are available somewhere in the system, either next to the data or elsewhere. The output of the tool can be chained to the input of another tool. So we had the notion of workflow. And at the end, we need to present that output to the user, and we call that applications, where we combine, in this example, series of data from different sources. This is an abstract example where we want to do climatology based on ERA5, which is the ECMWF reanalysis, CIMIP6 data, and maybe an SQL database holding observations here. The challenge is that really we have to deal with petabytes when it comes to the reanalysis and the ESGF data to some sort of kilobytes to the decision makers. So the system really needs to cut us for all those scales. And the issue was not to have anybody disappointed, because the researcher, they want to have access to the petabyte, but the decision maker, they just want a map. So that's one of the main challenges we have to address here. And lastly, what the European Commission asked us was that the system should be operational. That means we need all sorts of monitoring, reporting, help desk, on-call support, and so on. That's the ECMWF operator rooms where they monitor everything's happening. So the CDS should be just one extra screen here. So implementation, who are the users? So we had 3 different kind of users. We have the developers. I will start with the bottom, who are people who can provide tools. They know how to write tools, which is a program that takes an input and an output. We have the end user, which can simply visit the website and interact with the applications. And then we have the intermediate layer, which we call expert, which can use the tools developed by the developer to provide application for the top layer, for the end users. So that's a bit of a synthetic image. At the very end, you have the data supplier. On the far left, you have an application that an end user will view. And then we have workflows below tools, which belongs to a compute layer. And then you have the adapters. And then you have the data suppliers. And as you go from right to left, you go from petabytes to kilobytes of information. What's very important in the middle is that we have something called a common data model, and I will come back to that. So we went to tender, and we have selected a nice little machine here, which is a private cloud running on ECMWF premises. It's quite beefy. You see we have 2,000 CPUs, virtual CPUs, 8 terabytes of memory, and 2.5 petabytes of usable disk. It's actually all duplicated, so there are 5 petabytes of disks and SSD in the machine, but we only have access to half of it. And at the time, we really wanted to take the opportunity to learn about cloud computing. So we have put a lot of effort in automatic deployment. And we use OpenStack HIT, which is the OpenStack own way of deploying machines and connecting them with virtual networks and so on, and virtual disks. CloudInit, which is something which was developed by Ubuntu, I believe, which let you modify a new virtual machine and inject some code. So the new virtual machine you create has some code to start with. And then we use Puppet to deploy. So we start by creating the VM automatically. With CloudInit, we inject some code so they can connect to a Puppet server. And from there, everything is deployed. And it's quite nice because I can create a full CDS in something like 10 minutes. So architecture, very high level. We have some internet-facing machine, a proxy, and some download machines. Then we have the web, so Drupal, and a broker, a catalog where all the data sets, and then many compute nodes here. And we have adapters. So we have an adapter with the ECMWF Mars, the ESGF, ESA-CCI, it's the European Space Agency on repository of climate data. And what I illustrate here is that we also have parts in the same machine running an internal Mars in which we put ERA5. And currently we have half a petabyte, but we are going to push another half petabyte. So in a month or so, we'll have 1 petabyte of ERA5 online in this machine. But from the point of view of the architecture, it looks like it's an external service to the CDS, but it's nevertheless on the same machine, so it's efficient. Okay, I'll skip. This is another way of a bit more detailed. very important, the broker, we have a broker in the middle which implements quality of service. So we cannot afford to fulfill everybody's request simultaneously. So the first thing we do is that we put any user's request, like a data download or a execution of a tool, into a queue. And then we have all sorts of limits. So we can say, for example, currently we say no more than 10 requests per user. Or we can have a limit per data set, no more than 40 simultaneous requests on ER5, and so on. And all that we can tune. We also have priorities. So we can say interactive use has a higher priority than people coming with an API. And then we have a lot of caching happening. And what I'm saying here is that this system is very new, so in order for it to be efficient, we will have to do a lot of tuning. Now, I know that most of you are also working on provision of data. So the way we do now, we decided to decouple the actual catalogs and so on from how we manage them. So we use Git, and for each data set, we have a directory in a Git repo with all sorts of files. So we have a small YAML file describing the data set. We have the abstract itself, writing in Markdown. We have some information on how to do forms. I will come to that, and so on. Description of how to access the data, and then we have all the data sets here. And that's what people at ECMWF are managing. And then we automatically feed 3 databases. One is GeoNetwork, so we can export our catalog using CSW or AIPMH. We have a Postgres where we have the actual catalog for the web, licenses, forms, and so on. And where is what, information for the broker to find the data, and then Solar for the faceted search. We have a cycle which is quite complex, and currently it's our bottleneck in the system, is that when we have a new data set, we need to understand how it fits in the CDS. So we try to do as few catalog entries as possible. So granularity is quite coarse. We don't want a large catalog. We want a catalog where people find things. So we want very, very few records here. And then there is a lot of quality going on. And we may have to create an adapter if it doesn't exist, and then we test, and we go past, and we iterate with the data providers. The one in light blue here is not implemented yet. I mentioned the quality assessment. That will be done by an external body. This external body has been selected, but they are not there yet in the cycle. So they will check everything from the quality of the metadata, the encoding of the data, but also the scientific value of the information. So I checked before I started the talk. It was 3,332. So hopefully by the end of the talk we'll have a bit more here. So we have a system here that you can play with, and we have a catalog. So nothing new here. As I say, we want our records to be as high level as possible. We've been working on the naming of the records, so the long names, very meaningful abstracts. And then what you have here, and I will focus, once you select a data set, in this case it's a reanalysis, you have an abstract, but also you have a form. So at the top you have a tab, say download data, and you have a form. And every data set has an abstract and a form. So what we did not want is to have links, hyperlinks to elsewhere. We want people to fill the form, and when they submit that form, we get the data for them. And all the forms are based on the same sort of system behind. So here, for example, this is seasonal forecast. You will see slightly different form. And in this case, it's the Earth System Grid Federation, the CMIP5, and you will see a form as well. And if you are familiar with the ESGF, you can find the information here, but you will see that we've actually put many models together in one single form because we want to have as few records as possible. So we discussed with people, they are next door to us, how to do that best, but we don't want to reproduce the Earth System Grid Federation portal. That's not our aim. Our aim is to reach out to a new community of users. So scientists will still go to the ESGF, but we want to make that more easy for people that are not used to those data sets. Okay, another example here in this case, it's a water quality indicator, so that's an example of a sectoral information system. Now, if you select data and you say retrieve, you have this sort of single download page where you see your requests, and then when they are ready, you can download. So remember, we go and get the data from various sources, and then put them in central place in the CDS for you to download when you are ready. Yeah. Now, of course, everybody asks for an API. And then the thing is that in the form, when you select the form, you can ask to see the code of the API. And here it is, here. It corresponds to your selection. So even if you select live, you will see this text in, this is Python, will change according to your selection here. And by the way, you see here that in order to download any data, you have to agree on the terms and conditions of that data set. But once you have done it, it's done forever. It's attached to your account. Now, I will come back more in details. That's the toolbox editor, where you can write some code, access, have all sorts of previous workflows, and have some results here. And here, for example, is an example of an application which see the impact of climate change on the production of wine. So you can select your type of wine, and you see how the different scenarios will affect the index here, which depends on each kind of grapes. So we have all sorts of plotting facilities here. That's another good example where this is an example for a sectoral. This is transportation, and that's a shipping route through the pole. So you see this bit of Russia here, and then you have the consumption in petrol here, and then based on the route and the scenario. So that's a very practical example of how you could use this climate data to do something useful. Now, these are demonstrators. So we try to do the climate data store in such a way so that people could do demonstrators, and then later we hope that people will actually use that thing operationally. Now, the common data model, remember we have all sorts of data here, and we want to retrieve them, and we want to make them available to the tools. And so it only works if these data are on a similar coordinate system, using similar units, and so on. So we did not invent anything. We know that the CF convention is there, that people have been working hard with CMIP and so on, and see more to come. So if you want, our convention is based on CF 1.7 plus more rigid convention. So we force variables. It's not latitude, it's lat. We try to enforce units, and so on. The aim here is very pragmatic. We want all this data to be accessible in X-array. I guess you are familiar with X-array. It's a Python package which has been developed to manage, to work with an NetCDF CF. Okay. Now, in practice, what we try to do is to push new data provider to follow this model. Existing data provider, of course, you cannot change what I have done. So what we are going to implement in the toolbox are mappings between existing data sets and this common data model. And I'm happy to announce that something else we pushed recently on GitHub, it's called CFGRIB. For those who know, or GRIB, it's a wrapper on top of ECMWF EC codes library and X-array, which makes a GRIB looks like an X-array. So you have a very simple example here where we open a GRIB file, and that's Python, and then you have your variable, and when you dump your variable, you see that it looks like a netcdf. That's the first version. We want that to be done lazily, so we don't actually convert the data, but it's kind of working. So that's one of the main building blocks of the CDS, and it's available standalone as well. Now, I think I can skip that. Okay. So remember, we had definition, we had tools. A tool is anything that takes an input and generates an output. And usually it's just a Unix command. Something that can take a netcdf in and create a netcdf out is a tool. And they are implemented by developers. Workflow is what can chain those tools. If you think of a shell script, that's what a shell script does. You call a command and then another command. So that's what workflows are. An application is something which is an interacting web page with maps and widgets and so on. So what we have, the toolbox, again, it's something we are building as we go. We have the basic operators. We have some statistical operations and so on. What I want to stress here is that this toolbox simply wraps existing libraries and tools. Okay, so NumPy for Python, but I don't know if you are familiar with CDO, which are the climate data operators, which are a selection of command line tools to manipulate netcdf. So anything that can be run as a Unix tool can be added to the toolbox. The editor here, just to show again, you have some code, you have the output on the side, and you have your example you have some examples and your workflows here, you have the code here, and then you have the result here. And I'm going to go a bit more in details here. So the workflow, remember that the idea is to copy a bit the IRI map room, but although they have their bespoke language, we say let's use Python because that's what people are used to nowadays. So at the top, at the top here, you have some definition of widgets, which will end up being those widgets here. So two drop-down menus, and then you have your function. The widget becomes the parameter to your function, and then you have a data retrieval, and then I've lost my mouse. Yes, here. You have some number crunching here, and then you have some plotting function here, and then you return the plot, and that's the output. So as a end user, if I use that application and I change the variable in the Dropbox, that code will be rerun with the new variable selected here, and I will have a new plot. And we have some help as well. So here are the list of all the tools we have. They are organized into namespaces, and we have some help here. Now, that's what we have currently, and I'm going to talk to you where we want to go. So more on the API. Now, every workflow we want to do, we want to be able to call through the API. So remember, we can retrieve data here, but if you have a workflow that does some number crunching, we want to be able to run it from an API. So from your workstation, you can run a workflow which you have pre-defined already on the CDS and get the output. People are asking, can we use the toolbox locally? So we are looking into various ways of doing that. So you have a user script here. What we will start with this very thin API, and with time we may want to move some of the functionalities. So we may want to move the ability to run the workflow on your machine and the tools also on your machine. Now this is a bit against the idea of cloud, so personally I'm resisting, but people like to run things on their machines. But we'll see where we go with that. What we are doing as well is trying now to embed if you know WMS, the web map server. So instead of having a fixed image, you can have a very simple workflow, data retrieval plus a plot, but at the end, you have an interactive map here. There is a lot of work because this is very pretty for demonstration, but it's only useful if you can do more than just pan and zoom. The other thing is that we want to also support legacy code. Okay, so this is some of you may know that. And put that in a container, and that's what we want to do. So we started that. If you have an existing piece of code in Fortran or every other language, we want to run it as a tool. And for that, the Docker container are a perfect tool. So here, once you manage to wrap your code into a container, you should be able to call it from the workflow here. And we've started. So that's an example where we have several contributors. We use Git, where they manage a sort of a layout of code here, where they have in the Git repo, they have the tools directory where they have a namespace here, and each tool has a tools.yaml that explains what the tool is doing, and a Docker file. And once you have that, you will see your tools on the side in the toolbox. And that's an example, which I don't know if you are familiar with R. It's also very popular. So the tools.yaml explain what the tool expects. It expects a file in netcdf, and it will create a JSON message. And I tell the toolbox, in order to talk to my tool, just put this information into a shell environment variable. And that's the Docker file, which starts from a ready-made image containing R that will be downloaded from the internet, from the repo of Docker files here. What is missing in this R-based image is the support for netcdf. So the next line is to bring netcdf. And then I copy my script, and the script is here below. It will load a few libraries, read the file, do some, in this case, it's just an histogram of, it's just binning the values, counting every value, and then create the JSON output, and that's the result. So here, this is a real-life example of the R script you saw earlier, to which we pass ERA5, retrieval 2-meter temperature for a given day here. And then we call the tool, and the tool brings back the JSON, which is then plotted here, and that's the plot of the JSON here. So this is new. I mean, new last week, so that's why it's in the future. But that's for us a way forward to have more and more tools in the toolbox. Okay, application, we have no application. The application, remember, is once you have a workflow, you can make a web page out of it and have end users using it. We don't have that, so the plan is to put it somewhere in the website and have a portfolio of application that people can find. And also for every data set, you have to have a sample application. So people can look at this application and see how they can use that data in their application. Something else we would like to do is to allow other websites to embed the result of an application. So this is the website of the European Environmental Agency, and they do some documentation. They talk about climate change and so on. And here, this is photoshopped, and that doesn't exist. But that will be a page running on their website, and here will be an application served from the CDS embedded in the article. The quality control, this is something new. We need to work on that. But again, each data set will have a tab quality and maybe some sort of a traffic light system of, and then some sort of report. This is a big piece of work. From my point of view, we just need to make sure we can put this information from a technical perspective. So for example, we can imagine that you have a sort of traffic light saying this, the access to the data is fast, so it's green. The format of the data is NetCDF, but it's not quite good NetCDF. Therefore, it's not so good, and it does not respect the climate data model, the common data models, therefore it's red. So this is the sort of thing we need to work on now. And the other thing we've been asked many, many, many times is the provenance. So if you have this map, how was it made? And that's also, these are more ideas now. We don't know where to go, but for example, we need to record the DOIs of each data set that were used to do the map, and maybe the Git hash code of the tool that was used to do the map. These are just ideas. As I say, we need to have a discussion with our quality control, because these are the people that want to have this information here. We want to do a bit more of a social networking, if you want. So sharing your workflow with colleagues, having a forum and people helping each other. This doesn't exist. And also ask an expert. That's something we may also want to do. If you need to look at this data, we may have a possibility to contact an expert directly. Now, the last point here is supporting these sectoral information systems. So what we are doing, so remember, I want to rewind a little bit. We want to provide access. We want to extend the climate data store to health, transportation, and so on. These people are from a different sort of community that we are. So there is no point in trying to force them to fit our model, okay? And because we have this cloud system, the plan is first to give them virtual machines in this system. So that's just an example. A node with some CPU, some memory, a public disk and a private disk, so they can put data, and the data they are going to generate, they can SSH to them from the internet. They are going to put on this public disk. If they put any data on the public disk, it should be available to the CDS. The private disk, it's for them to do their number crunching here. And then we will just have to put in the CDS an adapter that can go over HTTP to get data from this public disk. We may want also to run tools that needs to run on their machine as part of the toolbox. That we have not tackled yet. And then if you remember that image from before, we are just going to add more nodes, but those nodes will be managed by external entities. So this we manage, that we manage, this will be managed by external contributor to the climate data store. So just an example, that's a picture of our cloud system. You could imagine that we have ERA5 in the corner here, but we can have the energy sector having a few machines and the water one as having more machines here. Now, coming back to cloud, if you think about it, we have compute layers. You know, I'm sure you are familiar with this sort of layering of the compute facilities. We have infrastructure as a service at the bottom, software as a service at the top. Platform as a service is a bit more difficult to find examples. So like a system where you can run an Apache or a MySQL system pre-existing and you use it. At the top you have Google Map, Outlook, Gmail, and at the bottom you just create your virtual machine. So that's how we see now what we are doing in the Climate Data Store. At the top we have the toolbox editor. It's really a software as a service on par with Google Maps if you want. So users using the toolbox editor will use the cloud, but they don't know it. They don't know that there are machines. They just use things in front. The SIS, they will have access to the machine and create their own. And in the middle, we are trying to build a platform for people to contribute tools, which they will not have access to the machines directly, but their tools will run somewhere in the platform. And we still have a lot of things to do. So you are all working with computers here. Things are not always as easy as it seems. So lots of bugs. We run out of memory. We need to understand the caching. We need to size the file systems and so on. But we are working on that. And I will welcome the feedback from everybody. So that's the sort of coding session. This is perfect because I think that's the last slide.